let's look at how we calculate the probability of a compound event. Now, in this lesson at 7th grade level, we're just looking at independent events. We're not looking at dependent events. Okay. What if we want to know, for example, not just the probability of A, which we looked at already, but the probability of A or B? Or what if we want to know what's the probability of A and then B? Okay, now in our problems, we want to identify these keywords. They're super important, okay? The word or tells us that we're going to add. So we can separate these two probabilities into the probability of A and the probability of B and just add them. And we already know how to do this. We did this already, right? And the same thing with this. These are what we've already learned. The probability of a singular event, just one event. We can find them separate and add. Okay, the words and then, that tells us to multiply. So again, we're going to separate our events A and B, and then we're going to times them to find our answer. All right, let's come back to a spinner. Oh, I didn't draw a little spinner thing on there. Okay, it's going to spin around and land on a number. So what's the probability of the spinner landing on a 3 or a yellow? Okay, so here's our compound event. We have two things happening. So we have two events. We have the probability of a 3 and we have the probability of a yellow. I'm just going to put a Y there for yellow. And or, remember, tells us to add. So let's find the probability of 3. Well, there's only one 3 and there's 10 sections on the spinner. And then yellow, there's 1, 2, 3, 4. So we're going to put 4 over 10. If we add them together, 1 plus 4 equals 5 over 10. And we can reduce that by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So our probability is 1/2. So there's a really good chance that we're going to land on a 3 or a yellow. Okay, next one. What's the probability the spinner will land on a blue or an even number? Okay, so we're going to go back here. Or tells us to add. So let's find the probability of blue. Again, I'm just going to use a B to save myself some space. And the probability of even. Okay, well, I only got one blue section, so we're going to put 1 over 10. And how many even numbers are there? Well, I've got 2, 4, 6, 8, 10. I've got 5 even numbers. So I'm going to add 5 over 10. 1 plus 5 is 6. 6 over 10, those are both even. So let's divide by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. So our answer is 3/5. What if we wanted to know the probability of spinning a green and then a 2? Okay, let's look back up here. Remember, and then tells us we're going to multiply. So we've got probability of a green, and then we're going to times by the probability of a 2. Okay, what's the probability of green? Well, there's 2 greens, and there's 10 sections, times 2. There's only 1 2, and 10 sections. Okay, from here, we just have basic fraction multiplication. We can multiply straight across. We can cross reduce. I like to cross reduce because it makes my math a lot easier in the end. So I've got, let's see, 2 over 10. I can reduce this way, or I can go across. Okay, let's go ahead and go up and down. Divide both by 2. So 2 divided by 2 is 1. 10 divided by 2 is 5. Okay, so now I can multiply across. 1 times 1 equals 1. 5 times 10 equals 50. Okay, so there's our reduced answer. Now, if we didn't do that, we could have just done 2 times 1 is 2, 10 times 10 is 100, and have 2 over 100, and that also reduces to 1 over 50. Okay, what's the probability of spinning a 9 and then a 4? Well, we have another and then, so that tells us we're going to multiply. So probability of 9 and then the probability of a 4. How many 9s? There's only 1 out of 10 sections times how many 4s? Oh, there's only one of those 2. Equals, there's nothing here for me to reduce up or down or across, so I'm just going to multiply. 1 times 1 is 1. 10 times 10 is 100. So there's a 1 in 100 chance. That means out of every 100 spins, I can expect for this to happen. Okay, so not very likely. It's like a 1% chance. Okay, this last example, it appears to be harder, but it's just the same thing. Okay, but this catches up a lot of my students. What is the probability of? Now I've got two things. Rather than having a compound probability on like one thing, just like the spinner, now we're going to look at a dice and a deck of cards. The deck of cards is colored cards, so there's 5 red, 10 yellow, and 15 green. And our cube, our dice is just 6-sided. Okay, so what's the probability of drawing? That should be a G. A red or a green card. This one just deals with the deck. Okay, so let's see here. Or a red or a green. Well, or tells us to add. So we're going to do the probability of a red plus the probability of a green. And that equals, how many cards are there altogether? Well, reds. There's 5 reds. How many cards? There's 10, 15, 30 cards. Plus the probability of green, there's 15 over 30. 5 plus 15 is 20 over 30. Oh, I love it when that happens. All right, anytime the two numbers end in 0, we know they're divisible by 10, and I like to just cross them off like this. Okay, so now I've got 2 over 3, but you can only do that when there's zeros. Okay, don't go crossing off any other numbers in your fraction. All right, the next one says rolling a 1 or a 5. So let's see. Again, we're going to add probability of a 1 or probability of a 5 equals, how many 1s are on the cube? There's just 1 out of 6. Plus, how many 5s? Well, there's just 1 out of 6. So that will give me 2 out of 6. And if I reduce that by 2, I get 1 over 3 as my fraction. Okay, don't worry if you're not confident at reducing fractions yet. Like if you could at least get the 2 over 6, you know you've got the right answer at least, and maybe you can get some partial credit from your teacher. I don't know, but you want to get to the place where you can reduce all of your fractions to the lowest terms. That would be the end goal. Okay, rolling a 2 and then drawing a red. So the key word here I'm looking for is and then. Okay, and then tells me to multiply. So let's look at probability of a 2 and then probability of a red. Well, how many 2s are there? There's just 1 out of 6 times a red card. Well, there's 5 reds out of 30 cards. Now, again, I like to reduce before I multiply because it makes my math easier. So I'm going to look either diagonal or I'm going to look up and down. 5 over 30 can reduce, so I can divide both by 5. So 5 divided by 5 is 1. 30 divided by 5 is 6. Okay, and now I'm going to multiply across. 1 times 1 equals 1. 6 times 6 is 36. So there's my final answer. Last one, what is the probability of drawing, sorry, you couldn't see that, could you? Of drawing a yellow and then rolling even. Okay, so we're going to do probability of a yellow, just use a Y to running out of space, and then says multiply. Rolling even, probability of even. So we're going to have yellow, how many yellow cards? 10 out of 30 times even number. How many even numbers on a dice? 2, 4, 6. There's 3 over 6. Okay, so I've got some reducing here. Again, I like to look up and down first before I go side to side or diagonally. 10 over 30, they both end in 0, so I can just slash off those. 3 over 6 can reduce by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. And there's nothing else I can reduce after doing that. So I can go ahead and multiply across. 1 times 1 is 1. 3 times 2 is 6. So there's a 1 in 6 chance of drawing yellow and rolling even.